In this video, I'm going to apply the concept of derivatives into solving problems that are meaningful to you, that are real world problems, problems that impact your lives. So let's say you're an investor. Someday you'll work and you'll put money into your retirement account, which mostly goes into stocks and bonds, right? So how the stock market behaves is of significant importance to you because that's going to influence your retirement fund and ultimately is going to influence your livelihood. So I want you to kind of understand how mathematics can be used to model problems that are meaningful to you. So here is a company called XYZ. The stock of this company is modeled by exponential function. Here is a side note. In the long run, stock market roughly grows exponentially. So this stock is modeled by this exponential function. So this function is P of t, price of the stock as a function of t, time in years, is given by 100 times e to the power 0.04 t. Just to kind of explain this function a bit, when t is equal to 0, the price of the stock, t is equal to 0. That means right now, what is the price of the stock? So it's going to be 100 times e to the power 0.04 times 0. Because t is equal to 0, that is 100 times e to the power 0, which is nothing but 100. But e to the power 0 is 1, that is going to be giving you 100. So the current price of the stock is $100. And let's see, how does the price of this stock change over time? Now you have learned derivative. Remember, the derivative tells you how something changes with respect to something else. And that could be anything, any pair of things. So far you have used it in the context of just mathematical functions, but it could be applied in the context of real problems, real world problems that impact you. So how does the price of this stock change with respect to time? So what we are going to do, we are going to find dp over dt. That means the rate of change of price with respect to time is going to be d over dt, 100 times e to the power 0.04 times t. So I'm going to take the derivative of this, which is going to be 100 is a constant, so I could pull it out, times the derivative of d over dt e to the power 0.04 t. Now I'm going to use the chain rule. Remember, derivative of e to the power x is just e to the power x. This is the only function that has the same rate of change as the function itself. So now, using the chain rule, what I'm going to get, I'm going to take the derivative of e to the power 0.04 t, and it is going to be 0.04 t. Then I'm going to take the derivative of 0.04 t with respect to t, and this part is the part where I use the chain rule, and that's going to give me 100 times e to the power 0.04 t times 0.04, which, by the way, is going to give me dp over dt is equal to 0.04 times 100 is 4 times e to the power 0.04 t. And by the way, this is a realistic expectation. A stock can easily grow 4% over a year. It could be even more, okay? In many of the stocks, particularly in technology stocks, the growth is even higher than that. But 4% is a reasonable growth expectation. And S&P 500, which is the index that kind of takes 500 most successful companies in the United States and track their progress. That's an indicator of the S&P 500 is the indicator of the stock market or the US economy or health of the US economy. And that S&P 500 over last 100 plus years maybe it has been growing right around 3.5 to 4% if you take the average. But most recent years, they have been growing. It has been growing very, very fast. But anyway, so conservative growth expectation 4% is pretty normal. So this is the rate of change formula, how the stock price is changing at some point in time. So now you could take t is equal to 1, and then your rate of change dp over dt is going to be dp over dt evaluated at t is equal to 1. That means after 1 year it's going to be 4 times e to the power 0.04 times 1. And that number comes out to be, let me just do the calculation. It comes out to be 4.16, maybe 32. Just approximately 4.16. Now you can calculate the rate of change for different years by plugging in maybe t is equal to 2, t is equal to 3, and so on and so forth. Now, one question you may be asking as an investor. So let's say at some point in time, so let's say you just started your job, you're 25 years old, okay? So your age is, let's say, 25. So you started working and you invested, let's say, for simplicity, $100 in this stock. At that time, let's say the stock is priced at $100. So you invested $100. Now, one of the questions that you may be asking, how long is it going to take for my investment to double or triple or quadruple? Okay? You have long future ahead of you. Like you're 25, you'll easily work for 45 to 50 years, easily. Okay? If you work for 45 years, you're going to be only 70, right? You may work up to 50 years or more. Now, having said that, you want to double your money, right? So you invested $100 in this P of t is equal to 100 e to the power 0.04 times t. You invested $100 initially, t is equal to 0. This amount could be anything, by the way. Okay, instead of investing $100, you could invest 1,000, 10,000, 100,000, or a million. Doesn't matter. But for simplicity, I said you invested $100. But you want to double your money, and you want to find out how long is it going to take. So if you want to double your money, what you want to see is that your investment becomes 200, whereas you invested $100 initially at time t is equal to 0.04 t. So this is what you want. This is your desire, that your money doubles. So now I'm going to divide both sides of this equation by 100. That's going to give me 2 is equal to e to the power 0.04 t. Now I want to solve for t. This is an exponential function, so I'm going to take natural log of both sides, ln of both sides, because ln and e are inverses of each other. So that's going to give me ln of 2 is equal to 0.04 times t, because ln and e are going to cancel. If I solve for t, that's going to give me ln of 2 divided by 0.04. And if I do the calculation, and it comes out to be roughly about 17.32. So this is roughly approximately 17 years. Okay. In about 17 years, you're gonna double your money. So if you invested $100 in this stock, after 17 years, it's gonna become $200. Now let me remind you, after 34 years, it's not gonna be $300. It's gonna be double of the $200. So after 17 years, okay, after 17 years, is going to be $200. After 34 years, you're still working, it's going to be $400. After 51 years, is going to be $800, and you can see now this is exponential growth, a very powerful growth. This is a mathematical concept. Everyone should understand how things or investment or wealth grows exponentially. And that is why, by the way, folks, the rich gets richer because they invest their money. On the other hand, most of the ordinary people, they have hardly enough money to make it through the month, so they don't invest. But if you invest small amount of money and let it grow over the years, and that growth is exponential, that exponential growth makes you rich and very quickly. So it's very important that you understand exponential growth. Make sure that you do and invest accordingly. When you start working, start investing small amount. So let's say you are 25 and you don't have much money, but somehow you manage to get $10,000. Let's say you got sign-up bonus $10,000, or you work for the first year and somehow you hustle and try to save money. You save $10,000. So how much is it gonna be when you retire? After 17 years is going to be $20,000. You invested $10,000, okay, when you started your job, right? So it's going to be $20,000. Then it's going to be $40K or $40,000. Then after 51 years, or when you retire, is going to be $80,000. And you can see the power of compounding. This is called the power of compounding, or exponential growth in this case, is very high, is very powerful. Now, if you keep investing, okay, if you keep investing money again and again and again over your lifetime, you will be surprised how much wealth you accumulate. So this problem is not only a math problem, but also a problem that impacts your life significantly, particularly your financial life significantly. And remember, whatever people say, money doesn't make you happy. I don't know whether money makes you happy, but money surely solves many of the problems in your life, many of the problems in your life that causes unhappiness. So remember, that cliche, the people say money doesn't make you happy, but I can assure you that money solves many of your problems, and when your problems are less, you are happier. I hope that this problem was helpful and you understand and take the lesson from this problem, and thank you very much.